In this video, we will discuss how to find eigenvectors under different conditions of eigenvalues. First among the different conditions is when eigenvalues are distinct, which means different from each other. To understand this, let us consider a matrix A 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5. In order to find its eigenvalues, let us write the characteristic equation determinant a minus lambda I equals 0. That will be 7 minus lambda minus 2 0 minus 2 6 minus lambda minus 2 0 minus 2 5 minus lambda. Determinant of this equals 0. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. Here lambda will be the root of this characteristic equation, which we call eigenvalues. Let us expand this determinant. We write this 7 minus lambda multiplied by this 6 minus lambda multiplied by 5 minus lambda minus 4 minus this minus 2, which will be plus 2 multiplied by this minus 2 multiplied by this 5 minus lambda minus this 0 equals 0. In order to simplify the calculations, let us write the terms in the bracket in the reverse order. So it will be lambda minus 7 multiplied by lambda minus 6 into lambda minus 5 minus 4 minus 4 lambda minus 5 equals 0. This will be further lambda minus 7 multiplied by product of these two brackets will be lambda square minus 11 lambda plus 30 minus 4 plus 26 minus 4 lambda plus 20 equals 0. That will be lambda into lambda square lambda cube minus 11 lambda square plus 26 lambda minus 7 lambda square plus 77 lambda minus 162 minus 4 lambda plus 20 equals 0. This will reduce to lambda cube minus 18 lambda square plus 99 lambda minus 162 equals 0. This is a cubic polynomial. In order to find its factors, let us find factors of this constant term minus 162, which will be minus 9 into 18, which suggests that lambda minus 9 is likely to be one of the factors of this cubic polynomial. We have to check whether lambda equals 9 satisfies this equation. So 9 cube will be 729 minus 18 into 81 will be minus 1458 plus 99 into 9 will be 891 minus 162. That will be 729 plus 891 will be 1620 minus 1458 plus 162 will also be 1620, that is 0. Since lambda equals 9 satisfies this cubic polynomial, we can say that lambda minus 9 is one of the factors of this cubic polynomial. The remaining factors can be found out by synthetic division. Lambda minus 9 is a factor of the cubic polynomial lambda cube minus 18 lambda square plus 99 lambda minus 162 equals 0. The remaining factors we will find out by synthetic division. For that, we will write coefficient form of this polynomial, which will be 1 minus 18 99 minus 162. Next, we will write opposite of this minus 9, that is 9 here. Now we will pull down this 1 and 9 ones are is 9. Now minus 18 plus 9 is minus 9. 9 multiplied by minus 9 minus 81, that will be 18, and 18 nines are is minus 162 plus 62 will be 0. This is the remainder when we divide this cubic polynomial by lambda minus 9, and since remainder is 0, this coefficient form of a quadratic polynomial, which will be lambda square minus 9 lambda plus 18. Now this quadratic polynomial can be factorized as lambda minus 6 into lambda minus 3. So lambda minus 9 multiplied by this lambda minus 6 multiplied by this lambda minus 3 equals 0. That gives us three values of eigenvalues: lambda equals 3, 6 and 9. Now we will find eigenvectors corresponding to the eigenvalues 3, 6 and 9. Let us first find the eigenvector corresponding to the eigenvalue, say lambda 1 equals 3. For that, let us first write the characteristic equation A minus lambda 1I multiplied by the eigenvector x equals 0 matrix. For reference, let us rewrite matrix A here once again, which is 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5. So this characteristic equation will then be this 7 minus 3 4 minus 2 0 minus 2, then 6 minus 3 3, this minus 2, then 0 minus 2 and 5 minus 3, that is 2. In place of this x, we write the three variables x1, x2, x3, and in place of this O, we write the column matrix 0 0 0. Now in order to find the values of x1, x2, x3, we have to reduce this coefficient matrix into an upper triangular matrix, which we will do by row transformations as follows. By successive row transformations R2 R1, then minus 1 R1, then R2 minus 2 R1, R3 plus half R2, and finally 1/4 R2, we get the coefficient matrix reduced to the upper triangular matrix as 2 minus 3 2, 0 1 minus 1, 0 0 0, x1 x2 x3, 0 0 0. By matrix multiplication, we get the linear equations 2x1 minus 3x2 plus 2x3 equals 0 and x2 minus x3 equals 0. The second equation is equation in two variables. Therefore, we have to assign parameter t to x3 so that x2 becomes t. Now with the help of the values of x3 and x2, we can get from equation 1 2x1 minus 3t plus 2t equals 0, 2x1 equals t, x1 equals t by 2. Now for convenience, we will put t equals 2, that will give x1 equals 2 by 2, that is 1, x2 equals 2 and x3 equals also 2. Therefore, the eigenvector, let us say x1, will be 1 2 2. If k is any non-zero scalar, then kx1 will also be an eigenvector. Next, we will find eigenvector corresponding to the second eigenvalue 6. Rewriting matrix A for reference, A equals minus 2 0, minus 2 6 minus 2, 0 minus 2 5. Let us find eigenvector for second eigenvalue lambda 2 equals 6. As usual, we will write the characteristic equation matrix A minus lambda 2, which is 6i, into second eigenvector x2 equals 0 vector O. This we write as 7 minus 6 1 minus 2 0, then minus 2, this 6 minus 6 0 minus 2, then this 0 minus 2, 5 minus 6 minus 1, into the eigenvector x1 x2 x3, which will be 0 0 0. Now by successive row transformations R2 plus 2 R1, then R3 minus half R2, and finally minus half R3, we get the row echelon form of this coefficient matrix as 1 minus 2 0 0 2 1 0 0 0 multiplied by x1 x2 x3 equals 0 0 0. Matrix multiplication gives us x1 minus 2x2 equals 0, 2x2 plus x3 equals 0. This second equation is equation in two variables. So we have to assign this x2 parameter t, that gives this x2 as minus t by 2. Substituting value of x2 in equation 1, we get x1 minus 2 multiplied by minus t by 2 equals 0. This 2 gets cancelled and we get x1 equals minus t. Now putting this t equals 1, we get x1 equals minus 1, x2 equals minus half and x3 equals 1. Multiplying each of x1, x2, x3 by this denominator 2, we get x1 equals minus 2, x2 equals minus 1 and x3 equals. So therefore the required eigenvector x2 corresponding to the second eigenvalue 6 will be minus 2, minus 1, 2. As usual, we can say that if k is a non-zero scalar, then kx2 is also an eigenvector. Next, we will find eigenvector corresponding to the third eigenvalue 9. Finally, we will find eigenvector x3 corresponding to the eigenvalue lambda 3 equals 9. For ready reference, let us rewrite matrix A once again. 7 minus 2 0 minus 2 6 minus 2 0 minus 2 5. We write matrix A minus lambda 3 I into eigenvector x3 equals 0 column matrix O. That will be 7 minus 9 minus 2 0, then minus 2 6 minus 9 minus 3 minus 2, then 0 minus 2 5 minus 9 minus 4 multiplied by, for x3 we write x1 x2 x3 equals column matrix 0 0 0. Now in order to find values of x1 x2 x3, we will convert this matrix into row echelon form by successive row transformations r2 minus r1, then minus half r1 and minus half r3, then r2 plus r3 and minus r2. The row echelon form will be 1 1 0 0 1 2 0 0 0 into x1 x2 x3 equals 0 0 0. Matrix multiplication gives x1 plus x2 equals 0 and x2 plus 2x3 equals 0. By writing x3 equals parameter t, we get x2 equals minus 2t, and using minus 2t in x2 here, we get x1 equals 2t. Now putting t equals 1, we get x1 equals 2, x2 equals minus 2, x3 is 1. So the required eigenvector x3 corresponding to the third eigenvalue 9 is 2 minus 2 1, and as usual, if k is any non-zero scalar, then kx3 is also an eigenvector. In the next video, we will see how to find eigenvectors when the eigenvalues are repeated. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.